Well now, in the same way that you can manipulate a power series using algebra, you can manipulate a power series using calculus. Let's take a look. Let's construct a power series for f of x equals 1 over 1 minus x squared on negative 1 to 1. Let's do that. Here's what we notice. If g of x is 1 over 1 minus x, which is the thing that we know about, then g prime of x is f of x. Go ahead, think about it. Take the derivative of 1 over 1 minus x. Okay, so you agree. The derivative of this is that. So we know that g of x is 1 plus x squared plus and so on, generic nth term, and so on. G prime of x, that's f of x, is the derivative of this thing. And that's 1 plus 2x plus 3x squared, and it goes. The derivative of the generic nth term is nx to the n minus 1, and so on. And so we have a power series for this function, and it's true on the same interval that 1 over 1 minus x was true to this power series. Okay. Construct a power series for the inverse tan of x on negative 1 to 1. Well, the inverse tan of x, wait a minute. The inverse tan of x is the integral of 1 over 1 plus t squared, right? I mean, the derivative of the inverse tan function is 1 over 1 plus x squared. So if we were to integrate 1 over 1 plus x squared, we would end up with the inverse tan of x. Do we have a series for this? Sure we do. We would take our series where 1 over 1 minus x is 1 plus x squared, and so on. And instead of having a minus x, we've got a plus t squared, which is really minus negative t squared. We'd take negative t squared and put it here and put it here and see what happens. So that's 1 plus negative t squared plus negative t squared squared minus negative t squared cubed, and so on. So what's the inverse tan of x? The inverse tan of x is all of this, right? So we take the antiderivative term by term. Antiderivative term by term, that's x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7, and so on. But then we got to deal with this 0. Like the antiderivative takes an area from 0 to x. There's some constant involved, right? There's some constant involved. Like there'd be a plus c at the end, but there isn't an end, so we write it at the beginning. Well, we know that the inverse tan of 0 is 0, so substituting 0 for x has to result in 0 on the right-hand side, so c must be 0. C equals 0 because The inverse tan of 0 is 0. So the inverse tan of x is 0 plus x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7, and it goes. What's the generic term? Well, the generic term is alternating. The powers are all one less than even numbers, and they're divided by even numbers. Sorry, they're divided by odd numbers, and so on. Let's do one more. Let's find a power series representation for the natural log of 1 plus x on negative 1 to 1. Natural log of 1 plus x on negative 1 to 1. Well, we know that 1 over 1 minus x is 1 plus x squared, and it goes. So we know that 1 over 1 plus x, that's 1 over 1 minus negative x, that's 1 plus negative x squared plus negative x cubed, and it goes. So we know that the natural log of 1 plus x is the antiderivative of this. It's the antiderivative of this. So, antiderivative, 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 and so on. We check ourselves. If x is 0, we need to get 0, and we do. There's no constant in the front. What's the generic term? The generic term is negative 1 to the n plus 1 times x to the n over n, and we go. This is a power series representation, meaning that the more terms of this that you graph, the closer you come to this function on that interval. That's it. That's the important thing to see. And I hope that it is clear how these functions approximate how these power series approximate the functions that we're trying to analyze. All right, we'll see you in class.